Let's take a trip in the Wayback Machine. Back in the 80s, we all had personal computers that ran DOS, and we were happy with it. By the time Windows came out, we were ready for a graphical user interface. In the early 90s, when Windows finally became usable, Windows sat on top of DOS, and Windows apps required the Windows runtime environment in order to be able to run. You may not remember this, but apps like Microsoft Word required Windows, but lots of people didn't have Windows installed, so you could, at the time, be running DOS as your normal operating system and just install Windows long enough to run Word and then close it up when you were done and Windows went away again, because people didn't really like Windows back then. Anyway, so Windows apps provide a consistent API for communicating with drivers and devices and so on. In my past life, I spent years writing device drivers for printers and screens for a DOS-based application in assembly language. Well, when Windows came out, my job, as they say, became redundant because Windows provided those services by hosting drivers internally, so I didn't have to write them anymore. So that's 1991. By 2001, we have a very similar situation. The .NET runtime sits on top of Windows, just like Windows sat right on top of DOS. .NET apps require the .NET runtime environment enabled to be able to run. .NET apps provide a consistent API for working with Windows, data structures, data types, and more. So you can think of the .NET runtime as just a Windows on top of Windows that provides more services for applications and developers. You can think of the .NET runtime as an environment that handles data types, memory management, APIs, and much, much more, as you'll see. So why are you here? Why does anyone care about .NET? Well, before .NET, software development required mastery of multiple technologies and authoring tools. You generally had to manually stitch together various programming tools in order to build your applications. For example, if you want to build a website, you had to learn VB scripting or JScript and HTML and some of the pretty ugly tools available for building websites. If you wanted to build database apps, you'd have to learn T-SQL and SQL Server most likely, or some other server application. If you wanted to build business applications, well, most likely Visual Basic would have been your language of choice. If you want to build Office applications, you had to learn VBA and manage to work in a COM-based environment with Office objects using that scripting language. If you wanted to build streamlined graphics applications, most likely you use C++ to do your work. .NET provides remedies for these issues. It provides an object-oriented view of Windows. That is, the .NET framework encapsulates lots of functionality into groups of classes. Application security is built in. You don't have to worry about providing your own authentication and authorization tools. It's all built into the .NET framework. Deploying applications on the .NET framework is easier as well, because all of the .NET application exists in containers called assemblies. And these containers, well, you can deploy them without having to add entries to the registry or worry about installing other bits and pieces. The .NET framework and your assembly is all you really need to run an application for the most part. You don't need to worry about versioning issues. How many times have you built applications and then attempted to deploy a newer version and dealt with all of the issues involved in that? The .NET runtime largely handles those issues without much effort on your part. Assemblies can be digitally signed. Using Authenticode as one of the options, you can see, or users can see, who authored the application. This helps users make intelligent decisions about which applications are safe to install and run. And unless you're using COM, and you can, although we won't cover that in this course, there's no need for registration. You don't need to write things to the Windows registry in order to run your applications. Now you can if you want, but you don't have to work with COM and the registry. In addition, all .NET languages are interoperable. You can write some pieces of your application in VB, others in C# and others in some other language if you want, and they can all communicate with each other. And this leads us to the concept of the .NET Framework architecture. If we stop and take a look at this picture, which I'm guessing you've probably seen before, it's hard to miss in any of the documentation about .NET, what you see at the bottom is Windows and COM+ services, which indicates that all this still sits on top of Windows and the features provided by Windows. Now, I will mention that there are versions of the .NET Framework that are currently running on other platforms. There are initiatives outside Microsoft to cross-port the .NET Framework to Linux, to the Mac, and so on. In this course, we'll be focusing on Microsoft technologies and using Windows and starting there. On top of Windows sits the Common Language Runtime. The Common Language Runtime is a set of services that provide all the features we'll use when running .NET applications. On top of that is the base class library. The base class library is a set of classes that provide all the functionality that you can take advantage of in your .NET applications. Now, within the base class library, we have various groups of classes. This diagram just shows a couple. ADO.NET and XML, for example, is a common way to work with data using the base class library, the .NET Runtime, and so on. Now, we also have various ways to build applications. ASP.NET allows us to build web applications. Windows Forms is the common name for the platform built into the .NET Framework for building Windows or client-side applications. In addition to all the user interface and classes, there is a common language specification which identifies what languages must provide in order to work in the .NET world. This specification is public, so anyone who cared to could write a language that fit in with the rest of these tools. Many vendors have done that. Microsoft ships languages like VB, C++, C#, and JavaScript with Visual Studio, but you can find lots of other languages like Python, COBOL, Fortran, and others that work in the .NET environment and use this same set of services and classes as the languages we'll look at here. Now, all of that is free. You don't need to pay a penny to get all of those tools. If you actually want to be productive, however, you'll want to also find a copy of Visual Studio. It was originally called Visual Studio.NET. Some people still call it that because it is the .NET version of Visual Studio. It's the Common Language Runtime that provides a runtime environment for all your .NET applications. We'll call it the CLR. And the CLR's purpose is to load and run applications that have been compiled to intermediate language, IL. Some people call it MSIL for Microsoft Intermediate Language, but it's just an intermediate language that the compilers create. Every .NET compiler creates IL as its output. We'll look later at how that IL becomes executable code. The CLR manages .NET-based services like memory management, garbage collection, removing things from memory when they're done, exception handling, that is, handling errors in applications. And it's important to notice that this is here at the CLR level, which means that applications have a standard and common way to bubble exceptions from one application or one procedure to another. So it's not up to each individual procedure to handle exceptions. It's handled by the CLR. In addition, obviously, the Common Language Runtime is in charge of loading and running applications. Let's stop and look at how the CLR runs code. The CLR allows you to run both managed and unmanaged code. And what do those words even mean? Unmanaged code is code that runs outside the Common Language Runtime. That is, code that was written before we had the .NET Runtime, like VB6 or native C++ code that were compiled without .NET. Although it's not the Common Language Runtime that loads these things, applications can cause these to be loaded, and they'll still work with the CLR running at the same time. Managed code runs within the CLR and benefits from all the CLR's features, memory management, garbage collection, and so on. Now, as I mentioned, the CLR and its compilers create MSIL on output. They don't create native code, they create IL. At execution time, the just-in-time compiler converts that IL code to native executable, and this little picture diagrams that. If we start with any .NET language, the language compiler at compile time creates MSIL code, as you see in the middle of the diagram. Then at runtime, there's a just-in-time compiler, often called a JIT compiler, that creates executable native code from that MSIL. You might think this is a drawback, but it actually adds some extra benefits. The JIT compiler takes the native processor into account. It creates code optimized for the local environment, if it can. That is, the JIT compiler can make decisions about how to optimize your code at runtime. Therefore, if you were to install your application to a computer, say with a Pentium 3 processor, I know there's some out there still, and then install it on a computer with a Pentium 4 processor or something even better, who knows, the just-in-time compiler could make different runtime decisions about how to compile that code into native executable so it would behave best for each individual computer. Now, it only needs to compile the application once. The compiled bits are cached locally. The performance overhead is very slight, if any. So you really needn't worry about, for most applications, any overhead involved in that first JIT compilation. And it's a far more complicated procedure that I'm showing here. It doesn't JIT the entire application, it only loads the pieces, it compiles the assemblies, and we'll talk more about what an assembly is soon. It only compiles the parts it needs and puts off compiling others until it actually uses them. Remember, the .NET runtime and, included with it, the Common Language Runtime must be installed on client computers in order to run .NET code. Of course, there's a question of how it's going to get there. On some computers, it will already be there. If you're running Windows Server 2003, for example, a version of the .NET runtime is already there. Microsoft Update, for many users, downloads the .NET framework for the user. It's not a small download, and it's not something you should take lightly. You can't install it from a floppy, for example, but what's a floppy anyway at this point? Let's take a moment and look at the BCL, the Base Class Library. This consists of classes that provide base functionality for the .NET framework, and many classes also that make your life as a developer easier. I sort of found that at any point, if there's something I need that I think other people may have needed before me, I don't write it myself. I look in the .NET Framework documentation, and I'm likely to find it there. This is a library of classes that are used by all .NET applications, and you should, as you become a more experienced .NET developer, become more and more aware of what's actually in the .NET Framework Base Class Library that will make your life easier. The Base Class Library contains a large number of classes, and you might be wondering, what is a class? Well, for now, think of a class as just a block of functionality, including properties, that is something that describes this class, methods, that is something that the class can do, an action it can take, and events, that is a way of providing notifications about the class, grouped into namespaces. And a namespace is just a grouping of classes in which every class has a unique name. The Base Class Library's namespaces group classes into common blocks of functionality so that all the classes dealing with file input and output are all in one namespace. All the classes dealing with data management are all in a single namespace. It's just a way of grouping things so you can find them. To get you started, here are some common, or things you'll use often, Base Class Library namespaces. For example, there's the System namespace. This includes all the essential support you'll need for programming, including base types like strings, integers, date, time, Boolean, so on. There's math functions, garbage collection, memory management, and more, all within the System namespace. Every application will use classes from the System namespace. There's no way around it. There's the System.data namespace. Notice that dot. They use the dot as a hierarchical organization tool. everything, for the most part, comes under the system namespace, so you will name it system.something. Now, there's other root namespaces. There is a Microsoft root namespace for things that applications that aren't using Microsoft tools might not use. But for things that are part of the base class library that every .NET application will use, the root namespace is generally system. System.data is a namespace that provides classes for working with data, including SQL Server, OLADB, ODBC, and so on. System.diagnostics provides the classes you need to diagnose, including event logging, performance counters, tracing, and process management. You'll find lots of good tools in the System.diagnostics namespace. System.globalization. Well, that provides fundamental support for globalization. That is, translating applications to work in multiple locales. And it's used throughout the entire .NET framework. So many different methods in the .NET framework use features from System.globalization to be able to provide, well, globalized versions of your applications. There's the System.io namespace, which provides fundamental support for working with, well, the technology is called a stream. And a stream is a class that provides functionality for moving data from one place to another, because that's what input-output's about, right? I/O, System.io. It's about moving data from one place to another. Now, the endpoint of that might be a disk file, so there's plenty of support in here for working with disks, files, folders, and so on. And throughout this course, this namespace gets used a lot because it's a great way to show off examples of other things. We'll look a lot at System.io classes in this course. The System.text namespace includes functionality for working with text encodings. It also includes the string builder class, which shows up in some of our demonstrations. There's System.text.regular expressions, and here you can see that the .NET framework isn't above creating multiple nested namespaces. There's System, System.text, System.text.regular expressions. Well, regular expressions provide a subset or a certain corner of text operations that allow you to provide support for robust parsing and matching of string data. System.web provides design time and runtime support for creating and displaying web applications. If you're using web applications, you'll be living in the System.web namespace. System.windows.forms is the namespace that provides all of the features you'll use when building Windows applications. All the controls, all the forms, all the features of Windows applications live in this namespace. System.xml provides support for reading and writing XML content. And here we've covered about 10 of the hundreds and hundreds of namespaces in the .NET framework. And we've just showed you the names. We haven't looked at any of the classes inside them yet. Throughout this course, we will focus on several different namespaces and the classes within them. Microsoft provides several .NET languages, including Visual Basic, C#, C++, JavaScript, and other vendors provide other languages like Python, Fortran, COBOL, and I don't even know what Python is, but I'm sure you do, and you'll find that you can use it within the .NET runtime environment. How do these languages interoperate? Well, .NET provides the Common Language Specification, which describes how a .NET language should work. In addition, the Common Type System, don't you love those three-letter acronyms, CTS, describes how data types should work together so that you can write code that uses a string and somebody else can write code in a different language that uses a string, and all of us can play along together. In the end, all .NET languages compile to IL, and we'll be looking at some IL to see how it all plays out. We're going to spend some time looking at a .NET application, and to do that, we'll need to think about what an assembly is. An assembly is what you get when you compile managed code. You compile it, you get an assembly. That's what comes out the other side. Theoretically, an assembly can contain multiple modules, although Visual Studio only supports creating a single module assembly. So that's all we'll see in this course. The output is either an exe or a DLL, just like any other environment, and actually these contain compiled IL and information about the assembly. That information is called metadata, and that contains a manifest that describes the assembly, procedures and types it exports, and other assemblies it requires. In a moment, we'll look at a manifest and see what's actually in there. You'll find version, name, culture, and security requirements. There's a list of other files in the assembly and also a cryptographic hash for each file, so the .NET Runtime can tell if the file has been modified. There's a list of public types, types that are exposed by this assembly, and a list of external required references, other things this assembly needs in order to run. We'll be looking at ILDASM, that's the IL disassembler, which comes with the .NET Framework to examine the contents. In just a moment, we'll take a look at a .NET assembly and see what's actually in there. So what are your options? You can create a large range of applications with .NET. Visual Studio includes templates for these items, among a few others: Windows applications, console applications, and to be honest, we'll be building console applications throughout this course because we don't know what your goal is. We're not sure if you're building Windows apps or web apps, so we'll go with the common ground and we'll build console applications. Because we won't be focusing on building user interfaces in this course, just language features. Console applications seem the safest way to build a common ground. You can build class libraries, libraries of code that other applications need to use. You can build a Windows control library that is a bunch of controls for Windows applications, or the same thing for web applications. You can build a web application. You can also build an XML web service, that is, a programmable object living on the web that someone can retrieve information from or interact with over the web. Well, it's finally come time to build our first .NET application. Using all the information you've seen so far, let's just jump in and give it a try. So you're probably thinking we're going to jump right into Visual Studio and start creating applications, but no. Let's step back for a minute and think about other ways you can build applications. The compilers that come with the .NET Runtime are all just command line tools. So you might try to, if you were so inclined, just do a start and try to find the compiler so that it's named CSC and we don't find anything. The C# compiler is named CSC, but it's not available to us. Why not? Well, when Microsoft installs Visual Studio or the .NET Runtime, they don't actually modify the DOS or the Windows whatever path for you. Instead, when they install the .NET Runtime, they create for you a special command prompt. Now, I'm going to go to the Visual Studio link in my Start menu, go to Visual Studio Tools, and now I'll find the Visual Studio command prompt. If I go to the .NET Framework SDK, I'll find the same sort of command prompt. Either one will do for now. I'll choose this one. You're thinking, oh boy, a new tool, like this cool new command prompt. It's pretty much the same old command prompt. The only difference is, if I look at the path, this one includes all of the Microsoft tools in the path. So if I type CSC, now it finds the command line compiler. There's my C# compiler. If I do CSC ? You see I get a list of all of the command line options for compiling code. Now, I'm not suggesting that this is the way to write code, but it certainly is a way to prove to yourself that these tools are available without Visual Studio, and it gives me a nice starting place. So I'm going to go to the Start menu and start Notepad. And I'm going to create my first C# application. It's not quite as productive as Visual Studio, but it gives us the idea of how to at least write an application. So I'll start by creating a class. Every application in the .NET Runtime requires a class. So I'll name this Hello World. Okay, so in C# I've got my braces to surround my class, and within my class I need to create a method. A method is a bunch of code that does some work. And in order for an application to work, we have to have a main method. So here we go. Public static void main. What do all those words mean? Public means it's available from outside this assembly, so the .NET Runtime can see it. Static means that well, this is tricky, because in order to work with the class, the .NET Runtime normally has to create an instance of that class, put one in memory for it to work with. But the .NET Runtime doesn't really know the name of this class. I gave it an arbitrary name, Hello World. The static keyword allows the .NET Runtime to call the main method, and the .NET Runtime will automatically create an instance of this class without having to know its name or anything. So the static keyword makes it possible for the .NET Runtime to run this procedure without really knowing anything much else about this class. The void keyword indicates that this procedure doesn't return a value, and the main, well, that's the name of the thing. Let's finish it up. That would be a comment. You probably knew that. And let's put the actual line of code that does something. Okay, so we've written our code, and we actually could even go in now and indent it intelligently. So I'll go back over here and maybe tab in. Makes it a little easier to read, I suppose. Okay, let's save this thing. And I'll save it as hello world.cs. That's a common extension for C# code files. Let me save that. Okay, I've done saved it. Come back over here, change the root directory, and here, because the CSC compiler is in my path, I can call it from anywhere. I'm going to type CSC test.cs. That's all it should take to build our output assembly. I meant to do that, really I did. You've got to type the name of the source file correctly. And actually in the command prompt, I can type H and type tab and it fills in the rest for me. So that seems pretty easy. And now we compile it and it completes successfully. Notice the enthusiasm with which the command line compiler indicates success. Okay, let's run it. Bingo. We have our first running C# app, and I bet you're really excited. Let's go do a directory here for hello world.star, and we'll see we have our original source file and our compiled executable. That compiled executable isn't very big. Of course, it doesn't do very much, but most of the code for that compiled executable really lives somewhere else in the .NET Runtime itself. Okay, let's investigate the code a little bit more. Back over here. We started out with a class. A class provides, well, a blueprint for behavior of a set of objects. We could create multiple instances of this Hello World class, and each one of them would have the same exact behavior. Now, because the only purpose of this class is to provide that main procedure, we never would create multiples at the same time in the same application running at the same time, but we could. That's what classes allow you to do. The public keyword here indicates the scope of the procedure. This indicates that it's available from outside. Static, as I mentioned before, means that we can create an instance of this class automatically so that we can refer to and call the main procedure. The .NET Runtime has to do that for you. The void keyword indicates there's no return value. The main is the name of the procedure, and you have to have a main procedure in your application in order for the .NET Runtime to be able to run your application. Now we have braces here indicating the block of code. Now if you noticed while I was typing, my tendency is to put the braces in together. I never type the opening brace, type the code, and then type the closing brace. That's just my personal style. You have to decide for yourself how you're going to type, but it's way easier to put the braces in first. Now within the braces, I have this comment. comments are just, well, comments to you in your code so you can read the code later and understand it. Of course, this code is pretty self-explanatory, making this comment pretty much redundant, but it's there. Here on this line of code, we have this long reference. System is a namespace. It provides, as you saw earlier, all the base stuff we need to run applications. Within the system namespace is a console class. This console class knows how to interact with the console window. That was our black screen we worked in, that DOS prompt. WriteLine is a method of that console class, which indicates what we want to do. We want to write some text to the console window. This text, in quotes, acts as a parameter to the WriteLine method. We're sending some information to the WriteLine method, telling it what to do. We're telling it to write this piece of text to the console window. Finally, parameters must be surrounded with parentheses. We could have more than one parameter. This method actually takes more than one, but it will accept a single parameter and display it in the console window. We end the line of code with a code separator, that is a semicolon in this case, which indicates the end of the line. You can break up your code across multiple physical lines pretty much any place you want, as long as you don't break keywords. For example, if I wanted to write the code that way, no problem, C# doesn't care. If I break it here, again, no problem, C# really doesn't care, as long as it finds that semicolon. On the other hand, you really can't do this. It doesn't know what to make of that, so I wouldn't recommend you try. In any case, this code is the same as our original code. Now you noticed here that I had to type the full system.console.WriteLine, that full reference. And what if I had lots of things that use that system namespace? Now you can write the code this way, but some namespaces' names get kind of long, as you'll see later, and you get tired of typing them every time. You can save some typing by going to the top of your file and adding up here an indicator of the different namespaces you might be using in this file. If I say using system up here, then down below I don't need to type system dot. Instead, console dot, let's get this code cleaned up a little, there we go, WriteLine will do just as well. Because now, when the compiler attempts to compile this code, it will say console. I don't know where console is. I really can't tell what class that is. Oh, look, he's got a using statement here at the top, and he's saying using system. So I'll look there for a console class. Found it. Okay, I can compile this code. You can have multiple using statements up here. I could add using system.io, another namespace we'll use a lot. And again, if I used a class down here that came from that namespace, it would say, I don't know what this is. Is it in here? Nope, not in there. Oh, I found it in here, so I'll use the class I found in that namespace when compiling the code. So this is our source code, and we took this and compiled it and created an output executable. What's actually in that executable? Well, to find that out, we'll need to disassemble the executable. So I'll come back over here, and from this command prompt, I'm going to run the IL disassembler, IL-DASM, and I'll pass in as a parameter our executable, hello world. So here is our IL-DASM utility. It comes with the .NET framework, so it's free, part of the framework, and I can now look at the various bits and pieces of my application. Now, in general, will you do this for every application you write? Not a chance. You probably will, for many months, never ever look at this again. So take that as an introductory exploration and file it away under the Isn't That Interesting file. Let's look at the manifest first. I'll double-click it to open it up, and you'll see in here a bunch of information in some weird format, which indicates a lot of different things for us. We first of all see that we're using an external assembly named MS Core Lib. That's the guts of the .NET runtime. So of course every application needs MS Core Lib. Here we have our own assembly named Hello World. Within there, we've got some information. Here's the hash algorithm, the version number. There's a module named helloworld.exe. There's a bunch of information about that, and that's about it. Since we're not really using much besides MS Core Lib, and we're not really exposing much information, there's not too much here that's interesting. Okay, so enough about the manifest. Let's look at the actual application. If we come down here, we'll see a bunch of information. The only thing I really care about right now is this main procedure. I'll double-click on it, and there's the code from the main procedure. You see we're putting a string, hello world. We're calling system.console. We're calling the writeLine method. And that's all the code. There's really not much to this code because we only called one method, right? So there's not much there. But the fact is, you could, if you really wanted, if you were some sort of crazed person that needed to really get a life, you could write the code this way. You could write code looking just like this and compile it into native executable if you wanted. Who needs that stinking C#? I can write this code because I'm a tough. Well, people really don't, but you can. IL is just as much a language as C# is. I don't recommend it, but you certainly can write this code yourself. In any case, feel free for any application to load that application up using ILDAS. And we'll do this again later in the course in various times to look at what's going on inside applications. Like I said, for most of the work you do, you won't really need to use either Notepad or ILDASM, but it's sort of interesting to know that you can.